So in this video, we're going to talk about how to solve systems of two or more inequalities. So you already know how to solve systems that have two inequalities. Remember what we do is we go to Desmos and graph the system, and then we look for the region where the shading overlaps to find the solutions to the system. So if you want to test whether a point is a solution to the system, you can just graph it on the same grid and see whether it falls within that region of overlap. So in this example, you can see that negative 1, 1 does fall in within the region of overlap for these two systems, so we know that it'll be a solution to the system of inequalities. So here are some rules for graphing inequalities. Remember, if the inequality sign is a less than or equal to or a greater than or equal to, our boundary line will be a solid line. If the inequality sign is a less than or a greater than, the boundary line will be a dotted line. Also, remember, we have to determine which side of the graph to shade. So we can plug in a test point like 0, 0 as long as it's not on the boundary line. So if the test point makes the inequality true, then you're going to shade towards the point. If the test point makes the inequality false, then you're going to shade away from the test point. So also, we're going to see some special inequalities when we're working on these systems. So special inequalities are like special lines. So for example, if we have the inequality x is greater than or equal to 3, remember that the boundary line is going to be defined by x equals 3. Well, remember, we had this mnemonic from back in Algebra 1 when we were talking about these special lines. If it's an x equals equation, then that means it's going to have an undefined slope and it's going to be a vertical line. So that's what you can see here. The boundary line is a vertical line through x equals 3. Also, since it's a greater than or equal to sign, that's why I've drawn in a solid line. So to determine shading, you can still use the test point, right? So for example, 0, 0 is not on this line, so I can use that as my test point. What's different here is that I only have one variable in my inequality, so I'm only going to be plugging in the x coordinate. When I plug in the x coordinate, I get 0 is greater than or equal to 3, which is false, so that's why the region that's away from 0, 0 is shaded here. Another special inequality you'll see are things like y is less than 3. So the boundary line here is going to be determined by y equals 3. And if we remember back from Algebra 1, we know that a y equals equation has 0 slope and it's going to be a horizontal line. So that's why the boundary line here is a horizontal line through y equals 3. Since it's a less than sign, that's why we have a dotted line. And also we can use 0, 0 to determine the shading, right? So we have 0, 0. So we're going to plug in 0 this time for y. So that tells us that 0 is less than 3, which is true. So that's why the side of the boundary line that's towards 0, 0 is shaded on this graph. So when you solve systems of two or more inequalities, it's all the same steps as when we solved systems with two. It's just that you keep repeating for however many inequalities you have. So you'll start off by graphing the boundary line of the first inequality and then shading the appropriate region. And then you'll just repeat for the second and the third and however many inequalities that you have. So alternatively, you can use Desmos, which is what we're going to be really doing more of in this class. So for example, suppose we wanted to graph this system. Okay, so you can see we have three inequalities now in this system. And if I wanted to, I could put these all in slope-intercept form and graph them on my grid. But really what we're going to be doing in this class is graphing using Desmos. So I'm going to show you how to enter these in Desmos. To get the inequality signs right, you're going to need to use the keypad because you can't get the greater than or equal to or the less than or equal to from your keyboard. So we do greater than or equal to, and then you can do the 3x from here, or you can just type it in from your keyboard. And then minus 7. Okay, so that's my first inequality. And then I have y is less than or equal to 8. Okay, and then we have x plus y. Okay, it's in standard form, but we don't need to rearrange it. Desmos will graph it for us. Okay, so you see now I have three inequalities graphed on this grid. And so what I'm interested in is where the solutions are, okay? And you can see that I have three inequalities here, right? And sometimes it's helpful, if you click this button here, it will remove that inequality from your graph for a second. And so it just kind of helps you identify where the region of overlap is, right? So we have this first inequality here, and then you can see now I've added in the second inequality. So I'm looking for this region of overlap right here for these two inequalities. And then when I add in my third inequality, you can see that the region where all three overlap is this triangle-shaped region right here. Okay, so you always want to get in the habit of doing that, is like looking at your graph and making sure that you know where the solution set is supposed to be, because that's going to be very important here in the next few lessons. So now let's try this system. So now we have four inequalities. So let's go ahead and type those into Desmos. So we have y is less than or equal to x plus 3. And then we have y is less than negative 2x plus 12. And we have x greater than or equal to 0, and we have y greater than or equal to 0. Okay, so now we have all four inequalities, but I'm just going to hide these for a second so that I can figure out where the overlapping region is. So here's my first inequality. When I add in the second one, so they overlap down here, right? So here's where I have red and I have this first inequality shaded also. Now we add in x is greater than or equal to 0. So now see the region where all three overlap is like right here where my cursor is. Let me add in the fourth one, and you can see like right here, this part, it's kind of this four-sided figure that I have here is where my solution set is going to be. So you can see here, I've outlined that in yellow. And so that's the region that I'm interested in, right? Because that's where I'm going to find all the solutions to this system of inequalities. So now you can go ahead and try this problem on your own. I want you to graph the system in Desmos and also try to identify where you can find the solutions. So when we graph this in Desmos, this is what our graph will look like. So I'm just going to go ahead and type these in once again. So we have x is less than or equal to 4, y is greater than negative 3x plus 6, and y is less than or equal to 9. Okay, so let me go ahead and hide these last two so we can figure out where the solution set is. So here's my first inequality. Then let me add in the second one. Okay, we can see here we have this region of overlap, right? This darkly shaded region. Now let's add in y is less than or equal to 9. And so we can see where all three overlap is this upside down triangle here, right? So that's this region that I've outlined in yellow. So that's where we're going to find all the points that are solutions to this system. So you can graph systems of two or more inequalities using the methods similar to those we use to graph systems of two inequalities. You can graph systems of inequalities by hand or using